Okay, so let's talk about problem B. In problem B, you're given n students and their respective shoe sizes, and what you're supposed to do is you're supposed to print a valid shuffling of these shoes, such that each student doesn't get their own shoe back, and each student gets a shoe size which is not lesser than their own shoe size. So that is greater than or equal to their own shoe size, right? Uh, let's build the intuition for the solution. Let's take a few students: student A, student B, student C, student D, student E, student F, right? And these shoe sizes are given in non-decreasing order, so they may be increasing, they may be equal, but never decreasing, right? So let's start with student A. Now student A has these many options to pick their shoe from, right? And let's say they pick student C. Let's say that student A got student C shoe. Now uh, we can assume that every student before C has a shoe size lesser than them, right? Because otherwise we can just like, if there are multiple students sharing the same size as student C, then we can just reorder them to bring C to the front of the list, right? So that means student C has these many options to choose from. So you see the number of options that a student gets to pick from is continuously reducing, right? And this happens all the way until we reach student F. Now student F has no option to pick the shoe from unless they can pick the shoe of student A, right? Which hasn't been picked by anyone, let's say. But this can only happen if student A and student F have equal shoe sizes, right? In this case, at least, right? Because it's always non-decreasing. So we can come to this solution where we say let's shuffle the shoes among the students sharing the same shoe size, right? So let's say student 1, 2, 3 have the same shoe size. Student 4 and 5 have the same shoe size. 6 and 7 have the same shoe size. What we say is let's shuffle these shoes among 1, 2, 3, these shoes among 4 and 5, and these shoes among 6 and 7, right? That way we are printing a valid shuffling, because uh, all of these students get a shoe size which is equal to them. So as in it's not lesser than their shoe size, right? So that's a valid shuffling. And when will this shuffling not work? It won't work when there is a student with a unique shoe size, right? As in there's no other student who has the exact same shoe size, and in that case we can show that no valid shuffling will exist because of the previous argument that we made about how the all options are limited and they're always decreasing. So the last, when the chain terminates, the last guy will not have a shoe to go back on unless the shoe size was equal. In that case it doesn't make it a unique shoe size. And so yeah, this can be implemented quite easily using a loop. So input is given in non-decreasing order, so all it takes us for us is a loop which goes through the shoe sizes and shuffles them. You could think of this as rotating the shoes. So like as in let's say students 1, 2, 3 have the same shoe size, then we can rotate their shoes. So 2 gets a shoe of student 1, 3 gets a shoe of student 2, and 1 gets a shoe of student 3. And this is valid because all of them share the same shoe size. So we can do this easily with the loop. Or additionally, if you're using C++, you could use std rotate, which does the same thing. So yeah, that's about it.